Assalamualaikum. My name is UMMI RAIHANAH binti ROSLEE and my metric number is AA190544.
Hi, Assalamualaikum. My name is Izzah Khalidah binti KHALID. My matrix number is AA192058. Okay, for lab activity 1, circuit number 1, as we can see here, when we run this simulation, the compressed air is already been moved into the actuator. But when we manually push the push button, and the valve, this valve, okay, will move to the right. So it will stop the air from supply to the actuator. Okay, the actuator will retract by the spring. Okay, but when we release this push button, the valve will move back to the left, so the actuator will back to its original position and supply can flow to the actuator. Okay, next, for lab activity 1, circuit number 2, this one, as we can see here, when we run this simulation, the air supply is already not been sent into the actuator. But when we manually push the push button, the valve will move to the right, same like circuit 1. So the compressed air supply will flow through the valve into the actuator and it causes the piston extend. Okay, if the push button is valve will move back to the left, which is the normal position, and the spring will slowly retract to the original position, the spring which is the piston. Okay, okay, next, for lab activity 1, circuit number 3, this one. Yeah, when we run, as we can see, the piston is already retracted by the force of the air. The compressed air supply flow through the actuator. But when we manually push the push button, the valve will move to the right. Okay, the compressed air supply will change the airflow from number 2 working point to number 4 working point. It causes the piston extend. When we manually release the push button, it will back to normal position. Okay, now let's move for observation part. Okay, for observation number 1, tabulate the list of components used in figure 1. So the component that we use in figure 1 is compressed air supply, valve, actuator, acting cylinder. Okay, now for circuit 1, we use 3 two-way valve with push button, which is mechanically operated valve. The second one for B1 is single acting cylinder, and the last one is compressed air supply. Okay, next for circuit number 2 is A2. Okay, 3 two-way valve with push button, which is mechanically operated. B2 is single acting cylinder, and the last one is compressed air supply. Okay, for circuit number 3, we use 5 two-way valve, pneumatically operated, double acting cylinder, and compressed air supply. For observation number 2, discuss the difference between the actuator below. Okay, for the first one, we use in the circuit number 1 and circuit number 2, and the other one is in circuit number 3. Okay, for the similarity is we manually push the valve. Okay, and next, when we push the valve, it will supply the compressed air to the actuator cylinder. And the difference between the actuator is circuit number 3 first. So circuit number 3, the valve, it is in normally closed circuit, and there is no spring in the actuator cylinder to retract the piston to its position. So this valve will help the actuator cylinder to push the piston to its position. While for circuit 1, the valve is in normally open circuit. There is a spring in the actuator cylinder to retract the piston, so it will back to its
normal position. As you can see, the first picture for circuit number 1 is a condition of a valve and piston when we run the simulation, and the right one is a condition for the valve and piston when manually push the push button. Same goes to circuit number 3. The first picture for circuit number 3 is a condition when we run the simulation. The right one is the condition when we manually push the push button.
Okay, next we move to question part. For question 1, describe the function of spring for component A1, A2, A3, B1 and B2. Okay, for A1, A2, A3, that is a directional control valve which is to push back the valve when we manually push it. The function of directional control valve is to stop the airflow and change direction of airflow. Okay, next for B1, B2, it is a single acting cylinder. So the function of spring for B1, B2 is spring force to return the piston to its position.
Okay, firstly open FloSim application, then create the circuit same as in lab report. Then turn on the run button to start the simulation. Okay, in this lab activity, we set the opening level to 10%, is this, and this at B2 and B1. Then we press the switch or air actuator at 5 two-way valve. Then observe how speed the piston moving. Then press again for piston back to original position. As we can see here, the function of one-way flow control valve to regulate the piston speed of pneumatic during advance and return strokes. When we press the switch, the manometer will take the reading of the pressure that has successfully inserted inside the cylinder. Okay, then press again. So for the example, we set the opening level to 100% at B1 and B2. Then we press again to see the piston moving, how speed the piston moving. So it means that the more we open the level opening at the valve, the more air can flow through this part. Okay, for the circuit of lab activity 2, this is the circuit. So for the observation 1, discuss the effects of setting B1 and B2 equal to 10% to the operation of the pneumatic system versus when they are set to 100%. If we set the opening level percentage to 10% of one-way flow control valve, the piston head delay when extend, while if set to 100%, the piston will immediately extend and retract without restriction. The function of one-way flow control valve is to regulate the piston speed of pneumatic drive during advance and return strokes. This is done through suitable restriction of flow rate of compressed air direction. The conclusion is, if the opening level percentage is increased, the faster speed of piston will be extend or retract. Okay, for the question for lab activity 2, question 1, discuss the function of this component below at B1 and at B2. Note that the direction of both is opposite to each other. This one, if we zoom at this, so the name of this component at B1 and B2 is check valve. The check valve of B1 is pointing upwards, while the check valve of B2 is pointing downwards. The function of the check valve is to prevent the pump and its generator from reversing and to prevent the medium from flowing back from the container. The check valve may also be used to substitute the auxiliary system at which pressure can increase above the pressure of the main system. Okay, for lab activity 3, firstly, open FluidSim application, then create a circuit, same as in lab report. The name of the circuit is Logic Function Implementation in Pneumatic System. In this lab activity, we're using 3 to mechanically operated valve, which is A1, A2, and A3. 2 pressure valve is V, 5 to pneumatically operated value, which is known as C, and double 18 cylinder D and air compressor. Then we need to turn on the run button to start the simulation. At the rest position, the compressed air flowing to 4 different parts, which is A1, A2, A3 and C. The air will flow through this part to making the piston in retract position. Okay, when I press this switch, C will move to the right and letting the air flow through the cylinder, making the piston to extend. When I press the A3, the valve moves to the right. The air will flow in 2 different parts, which is this and this, and to making the piston return back to original position. If I press A1, the valve will move to the right and let the air flow to the B, which is 2 pressure valve. B will move to the right, block parts of A2. Same goes if I press the A2. The 2 pressure valve will block this part, so the air does not flow through this part, so you need to press the valve at the same time to let air flow to valve C. Okay, lastly, at valve A1, A2 and 3, I need to press once only, and then the valve will move to the actual position. But when I press valve C, I need to press manually because it does not have the spring return.
Okay, next for observation part, Describe how to activate the actuator below. Okay, there are two ways to activate the actuator. The first one using the valve C, and the second one using the valve A3. Okay, so the first one, press the valve C and the valve will move to the right. Okay, the piston change the position and compress is applied to the actuator cylinder. Or we press the valve A3 and the valve will move to the left. Okay, and then it will supply compressed air to the actuator cylinder. Okay, as you can see, the first picture on the blue line, it shows that the compressed air supply will flow through the valve to the actuator. And the second picture, the dark blue line, okay, from A3, which is valve A3, the compressed air flow through the valve and to the actuator cylinder. Okay, now let's move for question part number 1. Okay, show the component used for logic function in the circuit. The first one is A3, which is 3 two-way valve with push button mechanical operated, and the second one is C, which is 5 two-way valve pneumatically operated. So for question number 2, state the logic function implemented. Is it OR, AND, NOR, or NAND logic function? So the answer is OR logic function. For question number 3, explain why C does not need a spring. Okay, C does not need a spring because it is pneumatically operated valve. A pneumatic valve is also known as a directional control valve, which is the major function of pneumatic valve is to switch airflow. Okay, so it changes the direction of compressed airflow from the number 4 working port to the number 2 working port. The valve controls the flow of compressed air supply. That means the valve will operate based on the different pressure at both of port, which is the right one and the left one. So basically, these valves are able to control the airflow pressure in valve.
Okay, that's all from us.
Thank you.